Good afternoon, viewers. Welcome back to Easy Mathematics. Last week we started with the Pythagorean theorem, that is the right angle triangle. Today we'll continue by looking at more examples in the Pythagorean theorem, or how to use the Pythagorean theorem to calculate for the length of a right angle triangle. So let's take the first example. The figure below, being this figure, is a rectangle with 12 centimeters long and 9 centimeters wide. Calculate the length of the diagonal, being this one. Now this question, we've been fortunate that they've drawn the diagram for us. In some questions, they will not draw the diagram. It will be given to you in a word problem form without the diagram. So you should be able to draw the diagram and know what you are finding. What are we calculating? We are calculating for the diagonal of the rectangular shape. So since we are calculating for the diagonal, we can use the idea of Pythagorean theorem. Why? Because if this is a rectangle, then we know that the angle being formed at the corner of this side is 90 degrees. And this is also 90 degrees. So we can take this as right angle triangle. You see, the question will not give you this for you to know that there's a right angle triangle. But you should know that if this is a rectangle, then there is an angle of 90 degrees. And this gives me a right angle triangle. So if this gives me a right angle triangle, what is the length of this? Because if I know this, I have to know the length of this side. But if this being a rectangle, then the side here and the side here are equal. Because we know that with rectangle, opposite sides are what? Are equal. So this is also what? 12 centimeters. Now this gives me a complete rectangle, triangle, right angle for me to solve for what? The diagonal. The diagonal becomes the what? The hypotenuse, which we explained that the longest side is always the hypotenuse, while this side becomes the opposite and adjacent. So if I want the diagonal, I can say x squared is equal to 12 squared plus 9 squared. So we take our time to solve for it. So this is going to give me x squared is equal to 12 squared is 144 plus 9 squared is 81. Putting these two together will give us x squared is equal to 225. Now here you want x. But since we want x and x is being squared, we will square root both sides in order to get x being alone. So we are going to square root both sides, and we are going to get x, a square cancel out x squared, leaving behind only our x. Now what is the square root of 225? The meaning of the square root is that what number times itself will give you this number. And if you multiply 15 times itself, you are going to get this number. So the square root of 225 happens to be what? 15. Now since we are dealing with length, we ignore the centimeters to make the calculation very simple for us. So what are you calculating? The length of the diagonal. So we are going to say, therefore, the length of the diagonal is 15 centimeters. So with this question, you have been fortunate that they draw the diagram for you. In some questions, they will not draw it for you. So you should know that anytime you are being given a rectangle, you have been given the length, or let's say the length and also the width or the breadth, and you want the diagonal, you just have a rough sketch like this. Once it is a rectangle, 90 degrees is being formed at the corner, then we use the idea of the Pythagorean theorem to calculate for the diagonal, the length of the diagonal of the given what? Rectangle. Good. Now let's look at the second example in this question. Now in this question, let's take a look at it. It says that in the quadrilateral ABC, so you have a quadrilateral being four-sided figure. So you have 1, 2, 3, 4. So in the quadrilateral ABC, AB is 3 centimeters, BC is 4 centimeters, CD is 12 centimeters, and angle ABC is 90 degrees. So you have it here. Also, angle CD, ACD, is also 90 degrees. Now, you have been asked to calculate the perimeter of ABCD and the area of ABCD. Now, here we are coming to look at how to calculate for the perimeter and area of a triangle. Now, what is perimeter at the first place? Perimeter is the distance around the figure. So if I add all the distance around the figure, that gives me the perimeter of the what? Of the figure. Good. So let's try to see if we have all the distance, then we add or put them together. Now, distance, perimeter is the distance around the figure. So I have this, I can add to this, I can add to this, I can now add this. But do I have this one? No. Since I don't have the length for this one, then I have to calculate for the length before I can even calculate for the perimeter and even talk about the what? The area. So look at the diagram. You can see that this diagram, you have two right angle triangles being joined together. So we are going to use the Pythagoras theorem. Once it is right angle triangle, use the Pythagoras theorem. So take this triangle and calculate for this side, being the longest side as the hypotenuse or your hypotenuse. So the longest side squared is going to give you the square of this and the square of this. But before we look at it, anytime you are being given a shape or shape that is being combined with different shapes, split the shapes. Always split the shapes. So if you split this shape, we are going to get it as this. So this is your A, this is your B, this is your C. So I have it here like this. This has been given as 3, this is 4. Now if I also want this one, I am going to get it like this. So I have A, and I have here as C, and I have here as D. So this is AC. This is AC. So with this right angle triangle, let's solve for AC, be the length for this. So I'm going to use the idea of the Pythagoras theorem. So I'm going to say the AC squared is equal to AB squared plus BC squared. AC is what I want. AB, what do I have? I have 3 plus 4 squared. Always don't forget to write your square, because it will affect your final answer. So we are going to say AC squared is equal to 9 plus 16. So we have AC squared is equal to, the sum of this will give you 25. I want AC, not AC squared. So as we all know, we are going to square root both sides. So this will cancel this. So now I can say AC is equal to 5 centimeters. Now the length here is your 5 centimeters. That is what you just calculated for. So if you just had or got 5 centimeters, it means this one is also 5 centimeters. So the AC that I have here, also AC, this is also 5 centimeters. Now, since I've been able to use the idea of the Pythagoras theorem to get this length, I already know CD. CD has already been given as 12. So this side is 12 centimeters. So I am going to use the idea of the Pythagoras theorem to solve for this AD, which is this side. So what will we do? We are going to say that the hypotenuse squared, so AD squared, is equal to AC squared plus CD squared. We are looking for the AD. So the AD squared is equal to AC. What do we have? We have 5, so 5 squared plus 12 squared. So here we are going to say AD squared is equal to 25 plus 144. If you put this together, you have AD squared is equal to 169. We want AD, not AD squared. So square root both sides is equal to the square root of 169. So if I square root this one, this will cancel out this. Now we have AD. What number times itself will give you the number in the square root? That's what we want. And you will notice that 13 times itself will give you 169. So the length here that you want, the length here is 13 centimeters. So I can now calculate for my eye, which says that I should calculate for the perimeter of this quadrilateral. But you notice that before we can even calculate the perimeter, we need all the distance, because perimeter is the distance around the figure. So I have this, I have this, I have this, but I have not been given this. So since the triangles, you can see that this is a triangle, this is another triangle being joined together. Since they are right angle triangle, apply the Pythagoras theorem. So with the Pythagoras theorem, we were able to know this length, and this length also helped us to calculate for this length. Now we can find the what? The perimeter. Because we have this, we have this, we have this, we also have this. So I, let's write here, I, we want perimeter. Now perimeter is the distance around the figure. So start anywhere. If you start from here, we have 13 centimeters plus 12 centimeters plus 4 centimeters. Then you can say plus 3 centimeters. Now put it together. If they are too huge, just take your time. What is 12 plus 13 plus 12? That is going to give you 13 plus 12, giving you 25. Then 4 plus 3, giving you 7. So putting this together is going to give you 2 and 3, being what? 32. So we can say P is equal to what? 32 centimeters. We are done. That is the perimeter. But before we have the perimeter, you see what he did. So we have to know that once this triangle is a right angle triangle, I will apply the Pythagoras theorem. Once it is right angle triangle, apply the Pythagoras theorem. Now look at the last part one. The last one, it says calculate the area of ABCD. ABCD. So we want the area of everything here. All the area. We want the area of this figure, which is the quadrilateral. Now, anytime it comes to area and you see two different shapes being put together, anytime it comes to area and you see two different shapes being put together, split them as we've done here. Know the area of this figure, know the area of this figure, and put them together. Only if the shapes are together. So here you can see that they've not removed any portion of this triangle, but rather they've added this to this, giving you a quadrilateral four-sided figure. So know the area of this, know the area of this, then you put it together. Whatever we are going to get becomes the area of the figure. You should take very important note of this. So here I can calculate my I here. We apologize for compressing them, making them too complicated, and I hope you can see, and it's very visible, right? Good. We can all see clearly from wherever we are watching from. Good. So I want II. Let's solve the II here. They said you should calculate for the area of the figure. So just as I explained, know the area of this triangle, which is the same as this. Know the area of this triangle, which is this one. Then if you know the area of this and that of this, put it together, and that will give you the area of all these figures, or all the figure you have here, being a whole as one. Good. But first of all, what is the formula? How do we find for the area of a triangle? It is easy to keep in mind, because the area of a triangle is calculated as half times base times h. Let's use the short form. We'll define it later on. So we say half times base times height. And one will ask, what is the base? What is the height? Always what will help you to know the base is the horizontal line of the triangle resting. Okay? The horizontal line of the triangle resting. So if you look at this triangle, which horizontal line is resting? Is this. So this is the what? The base. If you look at this triangle, which horizontal line is resting? it is always the one that is being perpendicular to the height. Now, what is the height? The height is the side of a triangle or of the triangle which is perpendicular to the base. Now, this is height. This line, it is also height. This, it is also height. But what differentiates between these two is that this height makes a perpendicular or is perpendicular to the baseline. And what is the perpendicular? Because it makes or creates an angle of 90 degrees with the baseline. But this height is referred to as what? As the slanted height. So when you are calculating for the area of a rectangle, we use the straight height and the base, and you multiply by half. And that is the formula for finding the area of a triangle. The area of a triangle. So now let's take this triangle and calculate for the area. So if I want the area of this triangle, I am going to say, let's say area 1 is equal to half times the base of this triangle, 3 centimeters, times the height of this same triangle, 4 centimeters. Now, since we've been able to look at how to multiply fractions and numbers, we can say clearly that this denominator 2 will cancel out the 4. So 2 here 1, 2 into 4, 2 times. Now we are left with 1 times 3 centimeters times 2 centimeters. What is the area? Multiply, and that gives you the area. So multiplying this is going to give you, this and this is 3 centimeters, and this is going to give you 6 centimeters squared. Because centimeters times centimeters is centimeters squared. That is why we always say the unit of area is the unit squared. So if I'm dealing with meters, then it's going to be meters squared. If I'm dealing with any unit you are dealing with, it becomes the unit squared. That is what? The area. So we know the area of this triangle, which is this. So the area of this triangle is 6 centimeters squared. Also, let us calculate the area of this triangle. So we can name that triangle as area 2, which is also half times the base. What is the base of this triangle? The base is 5 centimeters times the height. What is the height of this triangle? 12 centimeters. Also, we can say that 2 will go into itself 1, 2 into 12, 6 times. So what do we have? We have 1 times 5 centimeters times 6 centimeters. What do? You multiply. So let's multiply. 1 times this will give you 5 centimeters. 5 times 6 centimeters is going to give you what? 30 centimeters squared. So the area of this triangle is 30 centimeters squared. What are we calculating for? They say you should calculate the area of A, B, C, D, meaning everything here. So if I know the area of this and I know the area of this, then the area of this whole figure is going to be 6 centimeters squared plus 30 centimeters squared. So we continue here and say area of A, B, C, D is equal to 30 centimeters squared plus 6 centimeters squared. And this is equal to 36 centimeters squared. And that is our answer for this. So today, what we've included to our lesson is how to calculate the perimeter of a figure, and the most important one, the area of a triangle. We just said that the area of a triangle is given as half times the base. The base is the line or the horizontal line that makes a 90 degrees with the perpendicular height, or is perpendicular to the what? To the straight height. And the height is the straight side that is also 90 degrees to the base, or perpendicular to the base. So if I want the area of just this triangle, multiply half by this that's the base, by this, that is the height. So you just substitute, you cancel out if possible, then you calculate it like as we've done on the board. So if here, let's say I'm to get a vectors. Let's say here should be A, B, C. And they ask you to calculate the area of ABC. The area of ABC. This is a complete triangle. I can take this as my base since it is resting, or it is the horizontal, and this as my height. So what is area? Half times the base, 12, times the height, 9. Then you cancel out if possible. Now 2 can cancel 12, but 2 cannot cancel 9. So don't take this to cancel the 9. But since 2 can cancel, 2 here 1, 2 here 6. Now you have 1 times 6 centimeters times 9 centimeters. You multiply. If you multiply 9 by 6, 9 by 3 is giving you 27. So 9 by 6 will give you 54. So you have your area as 54 centimeters squared. That is if I want the area of this side. So what you should know is when it comes to area of a triangle, know the formula, which is given as this. You should know. Very, very important. And therefore, if we are going to treat the area of triangle again, that will be probably next academic year. So that is it for this question. We were asked to find the perimeter, but we have explained what to do to know the perimeter and also know the area of the figure. Now let's look at the last question. Now the last question was a mock that was written by all Methodist school in the Greater Accra region. And unfortunately for them, those who were able to solve this, being a past question for our predecessors, will be able to answer this question. So what they did was, instead of them labeling A, B, C, D, they labeled it P, Q, R. So here you can see that this is A, B, C, D. But when it was given to the current Methodist student as a Methodist mock, they did it P, Q, R, and they gave them the area of the figure, which is 36 centimeters squared. And when we calculated the area of this figure, we also had 36 centimeters squared. So the opposite of this was given to students to solve. And this happens to be a past question. And that's all we have to know. Once we know the topic, even when it is being tilted or given to us the opposite way, we should be able to solve it. So let's see how we have to solve this question. If it's supposed to come, or if we are to meet this thing, God willing, somewhere in 13th August. See what we got to do. Or 12th August. The area of the figure below is 36 centimeters squared. So they've given you the area of this figure. That the area of everything here is 6 centimeters squared. 36 centimeters squared, sorry. Angle PQR is equal to PRQ. So PQR is equal to PRQ, which is 90 degrees. So you can see the 90, you can see the 90. PR is 5 centimeters. So you have been given PR as 5 centimeters. So we have here 5 centimeters. And QR, 4 centimeters. So they've given you QR, also 4 centimeters. Calculate the length SR. Where is SR? SR. And also the length PQ. PS. P and S. Now this is a simple question that we are supposed to solve. Now the preamble has given you the area of the figure. So with the area of the figure, we can calculate the given length. So what are we supposed to do? Now, once you are able to identify the triangle to be right angle triangle, use the idea of Pythagoras theorem. So if this triangle happens to be a right angle triangle, then I have to calculate for this side. So if I know the length of this side, then at least I'm trying to get close to the solution of the problem. Now, if this is a right angle triangle, where is the hypotenuse? The longest side. So in terms of vectors, the longest side happens to be PR. So the Pythagorean says, the theorem states that the hypotenuse squared is equal to the other two sides sum squared. So this is going to be this side. We are looking at this triangle. So if I'm to split the triangle, just as we said, I am going to get this as P, like this. So this is Q, this is R. Then if I also draw this one, I'm going to get something like this. This is P, this is R, this is S. So the QR here is 4. PR, 5 centimeters. And PR, this is also PR, so 5 centimeters. So now, here I can't use the Pythagoras theorem because I don't have two sides to find the other side. But since this one, I have two sides, I can solve for the other one. So using the Pythagoras theorem, the hypotenuse, PR squared, is equal to the sum of the square of the other two squares, two sides, summed together. So I'm going to say PQ squared plus this one, QR squared. So PR, what do I have? I have 5, so 5 squared. PQ, I haven't been given, so I'm going to maintain this, plus QR, I have 4 squared. So the square of this is 25, PQ squared plus 16. We group like minus 16 is equal to PQ squared. Subtracting is going to give us 9, which is equal to PQ squared. I want PQ to stand alone. So what do I do? Square root both sides. So the square root of 9 is equal to PQ squared, also in the square root. So this will cancel out this. Now I have PQ to be 3 centimeters because the square of 9, the square root of 9 is 3. So now this side is 3 centimeters. Now if this side is 3 centimeters, how would that help me to calculate for my SR? If this side is 3 centimeters, how would this help me to calculate? Because if I'm to write the 3 centimeters here, I'm going to get it somewhere here. So how would this help me to know this? But the question has given you a preamble which is going to help you to solve for it. You have been given the what? The total area of this figure, or the area of this figure, as this 36 centimeters. So what am I supposed to do? If they've given me 36 as the area of this figure, then let me calculate the area of this figure. Because if I know the area of this figure and I subtract it from the area of the whole figure, this will give me this one. So let's calculate for area of triangle PQR. Area of triangle PQR. Now what is the area? What is the formula? What did we say? We said area is half times base times height. So if I want the area of triangle PQR, then I am going to multiply the base. What is the base? 4 centimeters. Times the height. What is the height? We want the perpendicular height. So 3. So times 3 centimeters. So the 2 here is going, the 2 is going to cancel itself 1. The 2 is going to cancel itself 1. And 2 going to 2 to 4 2 times. So I have 1 times 4. Sorry. I have 1 times 2 centimeters times 3 centimeters. Multiplying this will give you 6 centimeters squared. So the area of this triangle alone, is the 6 centimeters squared. But the question has given you the area of the whole figure. So if I know the area of this, subtract this area from the whole figure, whatever you are going to get becomes the area of this. So let's calculate. Area for this. So you are going to say area of triangle PRS. PRS is going to be 36 centimeters squared minus 6 centimeters squared. This is going to give me 30 centimeters squared. So the area of this figure is 30 centimeters squared. Now, how can I calculate SR? This is the area, 30 centimeters squared. How can I calculate for this? So that I will get this. Now, assume you are calculating for the area of this triangle. If I am calculating the area of this triangle, then the area is going to be half times base times height. Half times base times height. I know the area of this triangle. How did I know it? The question has given me the total area of the figure. And I have been able to calculate the area of this figure. So if I know the area of this figure, I will subtract it from the total area, so that whatever that I'm left with becomes the area of this figure. So I know the area of this figure as 30 centimeters squared. Now put this in your equation. Assume you are finding the area of this triangle. The area is 30 centimeters squared. So this is going to give you 30 centimeters squared, which is equal to half times base. What is the base? The base is 5 centimeters times height. What is the height of this triangle? The height of this triangle is SR, which happens to be what you have been asked to calculate for. So what are we going to do? Since 2 cannot cancel any of this, please do not say that 2 will cancel the 30. No. This is multiplying. This is multiplying. So we can only cancel here. But since the 2 cannot cancel, we will multiply and say 30 centimeters squared is equal to 1 times this will give you 5 centimeters SR all over 2. Fraction cancel out with the LCM, which is 2. So we are going to say 2 will multiply, 2 will multiply. So this will cancel out this. Now we are going to get 2 times 30 centimeters squared is equal to this. So this is going to give us an equation of this times this is 60 centimeters squared, which is equal to this. So 5 centimeters SR. I want SR. So I'm going to divide both sides by 5 centimeters. Divide by 5 centimeters. So now the centimeters will cancel the centimeters with a 5, leaving behind only SR. Now the centimeters here are 2. So this one will cancel one of it, leaving behind only 1 centimeter. So 5 here 1, 5 into 60, 12. So you see that we have 12 centimeters being equal to SR. So SR is equal to 12 centimeters. So the length for this is 12 centimeters. Now you want PS. If this is a right angle triangle, hypotenuse squared giving you this, you solve for it, and that gives you 13 centimeters squared. So you see that it is this question that they tilted it. They just gave you the opposite. Here you were asked to calculate for the area, which is the 36 centimeters squared. And here they've given you the area, and they are saying you should calculate for the length. And this is how the Pythagoras theorem can be given, being in basic 8 or in form 3. Next time when we meet, we'll look at the application of the Pythagoras theorem. where a ladder will be leaning against a wall, and you'll be asked to calculate either the height of the wall, the foot of the wall away from the ladder, or the length of the ladder. That is the application of Pythagoras theory. Thank you for staying tuned. Drop a comment if you have question or suggestion on today's presentation. The name is Christian. Please subscribe and share. See you next time. Bye-bye.